Hi, everybody. Dermot O'Shea here. I'm the host of the Antenna podcast, and today I'm delighted to have Ben Culver on. Ben, do you want to introduce yourself?
Yeah, my name is Ben Culver. I'm the CEO and president and co-owner of a company here in San Diego called Southwest Antennas. I've been here for almost 13 years, 13 years this April.
Awesome. Yeah, so it's good to have another San Diego antenna CEO on the line. But Ben, what got you into antennas in the first place? Where did you get started? And maybe from there,
Yeah,
tell us about your career to date.
yeah, I was thinking about that question, and it's kind of a long story. So I've always been into technologies and computers and stuff as a kid. I grew up in the 80s, and I was lucky enough to have a high school that had an electronics program for 4 years that I took. And I did that. And then when I was 17, 2 days after my 17th birthday, I joined the U.S. Navy for 6 years. And I went into the Navy and I became a fire control electronics guy. And I spent 6 years there and went through school there and very rigorous schooling and education around that. I spent about 4 years on a ship. Uh, and then in 1996, I got out of the military and I went to work for Maycom and I started designing power amplifiers for Maycom. I did that for a couple of years and I wanted to move out of Southern California at the time, so I moved back to where I grew up in the Portland, Oregon area, and I went to work for a company called Cadence Design Systems, and I worked there for 5 years, designing all kinds of different RF microwave products for a variety of commercial customers. And then right around 2001, Cadence closed their design center, so I went to work for one of my customers, and that was a company called Advantest. They're a Japanese company that does test equipment design. So I worked there for 2.5 years, and then they closed their design center down. And that was twice that happened. And I was working as an engineer all those years from Maycom through Advantest. And so I decided to get into business development, and I went to work for an antenna company in Vancouver, Washington. And I spent about 5 years there. I ended up managing their military aerospace and instrumentation division. Uh, and that's where I really got into the design and manufacturing of the antenna in the antenna space. And I left there and went to work for another company in the environmental monitoring industry. And that was antenna related. We designed satellite transmitters and antennas for NASA and for NOAA. I did that up until 2013 when I met my partner Les, and he had started Southwest Antennas in San Diego, and about 5 years prior to that, and he had grown into a small company. It was about $1 million a year in sales. He had about 6 or 7 people, and I decided to move back to San Diego and join him. And over the last 13 years, we've grown the company into a $25 million company with 130 people, and we're building about 150,000 units a year of 2,000 different part numbers. And it's a successful company, and we continue to grow year over year, and it's been like 35 years of just compounding, growth, moving around the market a little bit, but always kind of ending up back on the antenna side.
Awesome. Well, congratulations on the success with Southwest.
Thank you.
Um, so did you get in? Did you have like exposure to antennas when you were in the Navy, or where did you first come across them?
Yeah. So as a fire control technician in the Navy, we had systems on board the ship that um, track targets with radar systems, and we would assign guns and missiles to targets, and we would work on all of those things and operate those things. So that's where I really learned about the very complex nature of antennas and how they work and how RF systems integrate to them. We're talking about very large antennas, dish antennas, um, antennas that put out 500,000 to 1,000,000 watts of power in a pencil beam to track a target. So yeah, that's where I learned about that, and then after I left Macom designing power amplifiers, when I ended up at Cadence Design Systems, we started working on handheld wireless products that had antennas in them, cell phones, um, a golf ball tracking system back in the day, uh, all kinds of different products that were of a wireless nature. And this is in the early 2000s. So before the complexity of the cell phones that we see today that have, I don't know, 8 to 12 antennas in them. Um, analog cell phones and first generation digital cell phones and things like that. And
Uh-huh.
so, yeah, I got a lot of background, but most of my background is in RF circuit design. You know, the antenna stuff, I've never been like an antenna designer myself. Um, I'm an RF circuit design guy. And when I got into the antennas as a business, I was more on the sales and marketing side and the business development side, trying to get uh, customer requirements into the hands of my engineering team so that they could design products for their applications.
And when you talk about the antennas there that you did in the Navy and we're working with, it sounds to me like if you're in the Navy, you really appreciate the importance of an antenna. Whereas as consumers, I know as people, it's not something they think about or notice or even care about, right? They just it's something. Oh, when you explain it to them, they kind of go, "Oh yeah, I didn't realize there was so many antennas in my phone," for example. But I'd imagine the Navy really appreciate the art of antenna design and how reliable antennas need to be for their job.
That's true. I can't tell you how many customers minimize or don't understand the importance of the antenna in an RF system. And if the antenna breaks, the rest of the system doesn't mean anything. You know, I always tell people that the antenna is where mechanical and RF meet. It's the only part of the system where both of those things meet, and they're equally important. And if you have a poorly designed antenna that's not mechanically sound or of a poor quality, your radio is not going to work well and your system isn't going to work well. Or if you have a really good mechanically designed antenna, but the RF performance is bad, you're not going to have a good radio system. And so what we try to do is we try to get ourselves positioned with our customers as far close to the front of the project as we can, so that we can work with them on the importance of the antenna design as part of the system. And I can't tell you how many times people come to us, probably with you too. People come to us at the 11th hour in a project and say, our antenna doesn't work well. We can't pass our testing, our gain, our return loss isn't good. We got to fix it, but we can't change anything because our design is done, you know? So we try to stress the importance of working with us as an extension of our customers' engineering team, like up front.
Yeah, absolutely. So, and you must like based on your the amount of projects you've worked on and your career there, you must have worked on some pretty cool stuff. Or like, what's the coolest project you've worked on, or something that you're really proud of, or something you can talk about that would be interesting to hear about.
Yeah, I have three things that I'm thinking of. The first was about 10 years ago. We were contracted by the federal government to design surveillance systems that would go into everyday objects, where you would put a microphone and a camera inside of a device, along with a radio, antennas, and other hardware. And I was thinking about this. We did a coffee cup, like a coffee mug at one point, where there was a camera embedded in the side of it and a microphone, and the top, say 3 inches of the coffee mug had to have liquid in it. And at the bottom of that mug, there was a surveillance package built in with the antennas, with the radio, with all of that, the battery. And it would be used by law enforcement to collect evidence in crimes. And so we've done a lot of that kind of stuff. We've done women's handbags. We've done emergency lighting signs. We've done all kinds of what we call concealments, which are in the commercial world. That's like an embedded antenna design, right?
Yeah,
Where you design an antenna to be embedded inside of a device, and then you have to tune it to the device so that it works well as part of that structure. So that was a cool project. Another one that I'm really proud of that we've done recently and that we have into production now is a very large and complicated 12 by 12 MIMO antenna array So imagine this is a dual band, um, almost like a cellular base station where you have panels mounted in a circle, so you get 360-degree coverage. But every sector, every 120-degree sector covers two different bands. And then that design had a bill of material with 1,600 different parts in it. And then we had to embed cavity filters into that for very narrow band operation. And we've built about 300 of those so far. And they're very complicated. They take about 4 or 5 days to build, and they're very heavy. They weigh about 45 pounds. They go up on top of a tower. So I think that's probably our most complex and high performance product that we've designed. So we've got everything from a small printed circuit board antenna that, weighs nothing and has maybe 2 or 3 parts on it, to very, very big, complicated sector antennas or array antennas that are like a big part of a subsystem.
Yeah, and that's done. You've designed these here in San Diego, in
Yes.
Southwest. Yeah, because I know, like, I think that's something maybe younger people, students, etc., don't realize, because they hear sometimes in college and antennas, they go, "That doesn't sound that exciting." But when you talk
Yeah.
about it's embedding them in coffee cups for surveillance, are doing those massive MIMO antenna arrays, I think they might realize it's really interesting. Have you seen like issues trying to hire engineers in the US? Because
Yeah, it's kind of a sad state of affairs, Dermot. We spent about a year trying to hire our next senior RF antenna engineer. And what we find when we go out and we look for engineers is we find a lot of people that have done commercial products, Wi-Fi, cellular, you know, pretty simple antennas that go inside of a device. But when you try to find somebody that's done a rugged, external high quality design, there's a very small number of qualified people in this country that can do that. And I would say 8 or 9 out of 10 resumes that we get are from people that are international. You know, I don't know if it speaks to the programs that we have in our education system in the United States, but it just doesn't seem like we're putting out the level of engineer out of school that we would need to hire. And
gotcha.
so we ended up hiring a brand new person out of school, which had some experience, and then we hired a senior guy that we could find. But it took a long time to find the right person. You struggle with the same problem?
Yeah, no, I've seen it I think that's one of the, purposes of the antenna podcast is to create more interest in the world of antennas, right? So, because everybody that works in antennas loves it, and,
Yeah.
and it's obviously it's challenging. It's, there's a lot to it, but, your examples there of those projects, I think people love that stuff, right? We love working
Hmm.
on with customers, solving problems and working on really cool stuff, especially when you get to see it in the field then afterwards, and what it's been used for, etc. But yeah, I think definitely in Europe and US, um, I think the courses, I see them in the university, but people aren't taking the courses
Yeah.
because, like, obviously, when you have another course that you may see that's AI or is using simulations, or something like that, it is probably more exciting than going back and doing some, equations to figure out how to do the theory of antennas, etc. So I just think maybe we need to think about how we market it within the universities, um, to make it like not look like something that's so old and antiquated, that it can't be applied to so many new technologies and new projects, So
It's a good point. I think when I've talked to some people in the past, why they didn't take more interest or stay in antennas is they don't want to get pigeonholed. They don't want to get so specialized in one area of design where you could spend your whole lifetime learning antenna design,
yeah,
and but if that's all you do, there's a limited number of companies to work for. Now, if you go do software design or AI design or mechanical design, there's a lot more job openings, I would say, for those people. But also, if you're a really good antenna designer, there's some serious job security in that and some really good
mm,
pay.
yeah,
Um, but it takes years. It's like learning to play a musical instrument, the guitar, the piano, or whatever. Uh, you can pick up the basics pretty quickly, but to really become an expert just takes a long time and a lot of experience.
Yeah. No, but as you said, like it's not just job security if you can do it. The amount of companies that are looking for antenna engineers from, the Mag 7 to like the primes in your area to
Hmm.
like government, like everybody that is doing any hardware in scale is looking for antenna engineers that are just not there.
Yeah,
You know
yeah,
what I
it's
mean?
true.
So
It's true.
it's
Yeah, I knew a guy that was working for a company that I used to work with, and he ended up going to Apple. And he designs now antennas for the Apple handsets, and that's a very extremely challenging set of mechanical design constraints when you're trying to get all that stuff to work in such close proximity to each other. But and it's only getting more difficult. I don't know if you see this in your industry and in the customers you work on, but the things that we were designing 10 years ago were far easier to do than what
mm,
we're being asked to do now.
oh yeah. Yeah.
Always smaller, always wider band, better specs, lower cost. There's these competing things that are happening that make the job more difficult to get done.
Yeah. Oh no, faster, smaller, cheaper. That's the world we live in. Oh,
Yeah,
even though
yeah.
we're not in consumer electronics, that's the
Oh
way.
yeah.
And the expectation of, because of the Amazon DoorDash culture that we live in, everybody wants it tomorrow. So that's just the way it is. But yeah, so Ben, like what we like to do here on the Antenna podcast is to pick a technical topic and just talk at wider length about it, and so we can learn from it and hear from something that you think is a real relevant subject to the area of antennas. So it's over to you on that.
Yeah, I was thinking about this question when you sent me the list of questions earlier, and I think simulation is a good place to talk. Um, so when you're designing an antenna, you you start with the electrical and the mechanical and the environmental specs. That's really the first place you start. And what we do is we put together something called a product design requirements document, which documents what it is the customer wants, what it is the product needs to basically be. And always the first technical step after you have a spec done is the engineers start to simulate. And for a long time, we used one simulation tool, and it wasn't well supported over the last few years. So we've switched to a new tool now, and what we're seeing is the speed of design iteration is improving. It used to take us 5, 6, maybe 7 times of simulation. And what I mean by that is simulation is a software tool that you use to simulate the electrical parameters, the RF parameters of the product, the gain, the bandwidth, the VSWR, the return loss, all the antenna specs. And once you have something that you think is close, you take it to the lab and you build a prototype and you go measure that in a real anechoic chamber, and you see how close your prototype matches your simulation. And it's never going to be perfect the first time, maybe the first 2 or 3 times, but we iterate that. We iterate that with simulation, and we end up getting to a product that is very close or meets all the specs or is very close to meeting all the specs. And then we essentially take that information back to the customer and say, here's our simulated results, here's our measured results. Try this out in your system, tell us how it works. And then we go back and we start productizing it. We start making it ready for production. We start building work instructions for it. We start building fixtures and tools to build this thing in production. But I think from a technical standpoint, without the step of a proper simulation with a good tool, um, you get nowhere very quickly.
Yeah. And what is the accuracy of it? Do you see, like how many times does the simulation match the measured results?
It depends on the product, but I like to say it's like almost the 80-20 rule, right? It's like the first simulation might get you 80% of the way there. And then you build a prototype and you go, wow, that doesn't match, or this is correct, but this is off a little bit. And then you go back and you do it again, and maybe you get to 90%. And then you do it again and you get to maybe 95%. And hopefully what we like to do is within 3 or 4 iterations, we try to be at a producible product.
Mm.
And it depends on the complexity. An easier structure might take 2 times. A very
Yeah.
difficult dual band high gain structure, one of the things we've been working on for the last year is a couple of things. Dual band high gain omnis, so that operate in multiple bands but have gain of 5 or 6 dB. Those can be very hard because you might get one band working well, but the other band isn't. And then you go back and you improve the other band, but it screws up the band that was working the first time, you know? And so there's all these competing things that happen with simulation and building things in the lab. And then the other product that we've been working on is horizontally polarized omni antennas, because our customers need that, where in a MIMO system, you want to have a vertically polarized omni next to a horizontally polarized omni so that you have 2 different polarizations. And that's how you get polarization diversity, for example. And so I think in terms of what, bring it back to engineers and what they can learn in school is really focusing on those simulation tools in school. What we find is the engineers that come out of school don't have any experience with those tools, and they
Mm.
have to learn everything on the job. And I hope in the future that the schools can do a better job at integrating some of that into the classroom.
Yeah. Well, we just had Professor Sharma from SDSU
Hmm.
on the podcast, and they definitely have the simulation tools, and they train the graduates on using those. They have
Oh,
a
that's
couple
good to hear.
different ones. Yeah, yeah, yeah. So I think even maybe we can include this afterwards on the website, but there are, demonstration versions you can get access to if you want to try out the tools as well.
Yeah, the student versions for sure. Yeah,
Yeah.
and they're sometimes they're free or they're very reasonable. Sometimes they're scaled down a bit, but yeah, the tool that we just switched over to is light years ahead of what we were using before, and it's cheaper. It's lower
Yeah.
cost than what we were using before, which is surprising. But yeah, I'm hoping that as we go into 2026, our product design cycle time will improve because the simulation tools just improve that much.
And how does how is the importance of the antenna engineer still present if you're using simulation, right? Because we get customers who say, well, sure, if you're going to simulate it, why don't I just buy the simulation software myself? And then I can design my own antennas in the future. But like how do you see, the importance of the creativity of the engineer, the experience of the engineer in antenna design when he's using the simulation tools?
Yeah, I think the first part of that question is it would be like reading Greek, right? Like if you don't understand all the antenna parameters and what they mean and how they interact with each other, you're not going to have a clue about using that software. And then a lot of times what you end up doing with this type of software, you have to design a mechanical structure first. And you have to import that into the structure. Or sometimes the simulation tool comes with a mechanical CAD tool that allows you to design this thing. So you have to get a structure into the tool first, and then you have to be able to set up that tool with all these parameters that you know what they are because you're an RF engineer. You know what all these terms mean, and you have to understand how to use the tool correctly. And then once you run the simulation, you have to be able to interpret those results to see if they're meaningful. And I think without the engineer involved, I just don't see how that could ever really be possible. I mean, maybe someday AI will be so good that you'll have virtual engineers, but I think we're still probably 20 or 30 years out from that at least. And like you said, the creativity side too. Uh, the human mind can think of things in a creative way that no machine ever can. And draw on those past experiences. Oh, I've done a similar product like this in the past. Maybe I'll use that as my starting point. Or I can take something I've done in the past and maybe modify it a bit and use that as my starting point. I think I think I answered your question there.
Yeah, no, it's good points, good points. Yeah, it's just a kind of a funny uh pushback I get sometimes when
Really.
I hear that. Yeah, yeah, yeah. But I can see it getting more powerful. I think AI will just help speed up
Yeah.
the simulations. Like, how can you give maybe the listeners an idea of, say, for example, the coffee cup situation? How much simulation would you need to? How much time would you need to spend on simulation for a project like that?
It gets complicated. Back in the day when we did that project, the simulation tool, you had to keep things pretty simple in the tool. Otherwise, the simulation would take days, if not weeks, to run, because the more complicated the mechanical model, the harder the simulation has to crank on those mathematical models. And so what we would do is we would design the product on a substrate that we thought was similar to the coffee cup, the similar dielectric constant of that material. And then we would get it close. And then in the lab, we would go build up a prototype and measure it. And then we'd start tweaking it in the lab. And if we needed to, we'd go back into the simulation and change some of those parameters to get the simulation to match more real world reality of what we actually built. But now today, with the tools that we have today, 10 years later, we could design that coffee cup as part of the simulation. We could put the radio chassis in the cup. We could put the wiring and the battery in the cup, and all of that would influence the simulation, because what we're really simulating is the electromagnetic properties of the antenna and how those are influenced by metallic, ferrous objects that are in proximity to that antenna. So now these tools are so advanced and so fast that you can include things in your simulation that you could never include before. And I think what's going to result is just much faster cycle time and less iterations of simulation.
Great information. Thanks, Ben. And Ben, where can listeners find out more about you and Southwest Antennas?
Yeah, so we have a really good website. We just rebuilt it last year. It's southwestantennas.com. You can go up to the site and you can find out everything about our company and our products. We're kind of a strange company in that we put all of our data sheets up online. We put our pricing online. If you want to buy a product and try it out, you can do that. You can go buy the product with a credit card online, and that's worked really well for us. And I would say about 1,000 of our 2,500 products are up there on the website. There's a lot more that we have that we don't currently have up there, but we're adding more all the time. We just launched our new automatic RF cable assembly builder tool to the website. So we're starting to sell a lot of RF cable assemblies to go along with our antennas. And shortly, we're going to be launching our RF gooseneck builder tool to the website. So we make RF coaxial goosenecks, which are like, you see bendable microphone stands. Imagine that, but with the cable assembly inside, so that the cable assembly holds its shape. So we're selling quite a lot of those, and there's so many different length and connector combinations and flex arm strengths. Just so many combinations that the customer can come and pick the connectors, pick the length, pick the strength, and it will configure a product for them, and then they can buy it online. So we have a lot of new features up there, and if people want to learn more, they can either contact us there or, call us at the contact information on the website.
Great stuff, yeah. And Ben, you're a great CEO of a great company, Southwest Antennas. Thanks very much for your time today. Really interesting conversation. And my name's Dermot O'Shea. I'm the host of the Antenna Podcast, and you can listen to more episodes on the antennapodcast.com. Thanks, Ben.
Thank you, Dermot. Appreciate it.